I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, in this video, I'm going to go into a little more detail on chapters 1.1. You should have already looked at the vocabulary, but I'm going to, again, explain in further detail what each of these words mean and how they might look. So the first thing we're going to look at is a point. Okay, and so we use just a dot to label a point or to identify a point. We use capital letters to name points. So we would call this point A. Use capital letters. Then we have a line. For a line, we are going to use a line with two arrows, one on either end. A line exists between any 2 points. So if I call this point A and this point B, this would be line AB, and I would distinguish it like that with the line above the A and the B. Again, notice those are capital letters because those represent points. So between the points A, B, there is a line. I could also put a lowercase letter here, and I could call this line L. So we could also label lines with a lowercase lowercase letter. Usually it looks like it's in cursive. Next we have a plane. Now, to identify a plane or to show a plane, we're really just kind of going to do a parallelogram. Okay, but what you need to understand is that this parallelogram extends in everywhere. So it's two-dimensional, okay? So you can sort of think like a piece of paper, but if that piece of paper just extended out forever. So a plane is defined by 3 non-collinear points. So point A, point B, and point C. Those are non-collinear, meaning they do not lie on the same line. I'll get to that in a minute. So we would call this, or we could call this, plane A, B, C, or we could name the plane with a capital letter, and we could call this plane K. So we could label it also as plane K, but that's assuming that you've got this identification on the plane here. All right, collinear points. Collinear points are points that lie on the same line. Okay, it's pretty self-explanatory. A, B, and C are all collinear. If I have point D here, that point is not collinear with A, B, or C. Now, there is a line between points C and D. So in this case, C and D are now collinear, but D is not collinear with B or A. Could I draw a line between A and D and B and D? Yes. But the 4 of those points are not collinear. A, B, and C are collinear. Then we have coplanar points. So coplanar points would be A, B, C, and D. Those are all coplanar. If I have a point out here, call that F, that is not on the plane. Now, I mentioned that this plane extends forever, and so you think, well, it could be on the plane. But this is how we would denote that it's off the plane, because it's not in what we've defined as our plane here on paper in a way that we can define it. So F would be not on the same plane as A, B, C, or D. There is a line, however, through any 2 points, if you remember. So I could draw a line between point F and point C. And if I do that, I've sort of denoted that here. What happens is that line is going through the plane. Okay, and that's kind of a weird angle, but essentially that line goes through F and through C and then straight through the plane. So C is on the plane, F is not on the plane. Okay, here we have line AB. Remember, we call that and write it like this, line AB. Let's talk about the segment. So we also have segment AB. The difference between a segment and a line is that a segment has 2 endpoints and a line has no endpoints. The way that we denote a segment actually would just be like this. So notice the difference between a line is that it has the two arrows, and a segment, it has no arrows. It's just the little line by itself. Okay, so segment AB would just be this part of the line. It would be all the points in between the two endpoints A and B. We could also call this segment BA. Why? Well, because all the points between A and B is the same as the points between B and A, right? It goes the same this way as it does this way. So we can reverse those letters and it doesn't matter. It goes the same with the line, so this is also line BA. So line AB and line BA are the same line, just as segment AB and segment BA are the same segment. Then we have array. So I'm going to redraw our line here, line AB or line BA. So array has only one endpoint. So I could have array AB, which would be denoted like this. Now what that means, array AB is talking about this. Okay, so it's got this one endpoint and it goes in the direction of B. It includes all of the points that are on the side, the same side as B on the line. Okay, what about array BA, written like this? So if you think about how the segments and the lines were reversible, that is not the case with array. Array BA is actually this, noted in green. And so as you can see, they do share some points, but once you get outside the endpoint, the points are different. So these are two very different arrays. Make sure that the first letter is the starting point and the second letter is the direction in which the ray is going. I'm going to add a point to this line, point C. This is still line AB. I could also now call it line AC. I could call it line BC. I could call it line CA. Hopefully you get the picture there. Let's talk quickly about opposite rays. Opposite rays share an endpoint. So an example of opposite rays would be ray BA and ray BC. So ray BA is going to be this, and ray BC is going to be that. And so the red and the yellow, they share this endpoint, and then they go in opposite directions. Those are opposite rays. The last thing I want to talk about is intersection. An intersection is anywhere that two geometric figures intersect or share at least one point. So if we think about two lines, these two lines have one point of intersection, and that is right here. We'll call that point B. So point B is the point of intersection. If you think about it, two lines can only have one point of intersection, and their intersection is always a point. The intersection of two lines is a point. It is possible for two lines to never intersect, in which they would be parallel. It is possible for two lines to be the same line, in which case they would always intersect. Most of the time you will see that lines intersect at one point. Now let's consider what happens when we have a plane and a line, and we actually already talked about this. All right, so I've got line AB intersects plane BCD at point B. So line AB intersects plane BCD at point B. Point B is on the plane, point A is not. So essentially that line is going through the plane. So the intersection of a line and a plane is also a point. Here we have the intersection of two planes. I'm going to call this plane M, and I will call this one plane P. So plane P and plane M, they intersect on that pink line. Two planes intersect at a line, and that is the pink line, and we could put some points here, and we could call this line AB. There's also obviously points here on the line. those points, every point on that line is on both planes because the planes intersect in a line.
I've been waiting way too long.